science stuff where Group 1 may explain.
Rate of reaction is the speed at which chemical reactions proceeds or take place. Or in much simpler terms, it is how fast or how slow a chemical reaction occurs. A reaction takes place when two or more molecules collide with each other and has the minimum and enough energy required to break the bonds of reactant. This is known as the activation energy. We can relate this definition to collision theory. It states that the rate of reaction is proportional to the number of collisions between reactant molecules, which means more collisions means faster rate of reaction. Chemical reactions can either be fast or slow. Fast reactions are reactions that occur in a very short time, a second or even a millisecond. For example, burning a match, combustion of fuel in cars, and many more. While slow reactions are reactions that takes longer time to occur. It may take hours, days, or even months. For example, rusting of iron nails, photosynthesis, piece of newspaper turning yellow, and many more. There are several factors that affect the rate of chemical reactions, mainly the concentration, pressure, temperature, surface area, and the use of catalyst or inhibitor. In this video, we will show you a fast and a slow chemical reaction, together with the several factors that affect the rate of reaction. Fast chemical reaction. For this experiment, we need a bottle, a funnel, a balloon, a mixing spoon, vinegar, and a baking soda. First step is to funnel the baking soda into the balloon. And also realize that scooping it with a spoon is not an efficient method. Next step is we funnel the vinegar into the bottle. Also, don't forget to create a mess. Clean it so your tabletop will not smell like your armpit. Attach the balloon into the bottle and pour the baking soda into the vinegar. Finally, enjoy watching as the vinegar and baking soda reaction takes place. Here are the observation and explanation for the experiment. Acetic acid reacts with sodium bicarbonate to produce sodium acetate with excess water and carbon dioxide. The factor that affected the rate of chemical reaction in our experiment was the surface area of the reactants. The smaller the size of the reactant, the greater surface area it creates. The increase in surface area gives a greater chance for particles to collide and react with each other, thus speeding up the reaction. We can observe this when we mix baking soda, which was in small sizes and large surface area, into the vinegar. The reaction happened immediately when we poured the baking soda into the vinegar, producing excess carbon dioxide, which was observed when the bubbles formed inside the bottle and inflated the balloon. Slow chemical reaction. For this experiment, we need a cup of water, a thermometer, a mixing spoon, plastic wrap, sugar, and yeast. First, we need to make sure that our water is warm but not too hot, around 95 degrees Fahrenheit. Next is we mix sugar into the water and stir until it dissolves. After the sugar has dissolved, mix in the yeast and stir until no clumps are visible. After mixing, cover it tightly with plastic wrap. Lastly, observe and enjoy as the mixture we've created forms an oddly satisfying foam that rises slowly inside the cup. Now, it's time for observations and explanation. The reaction we've created was an example of slow biochemical reaction. We can think of biochemical reaction same to photosynthesis, where plants convert carbon dioxide, water, and sunlight into energy that it can use to grow. In this experiment, yeast is a living organism that uses carbohydrates or sugar to produce energy and release excess carbon dioxide. We can observe the production of carbon dioxide when the mixture creates foam that rises inside the glass. This process is also known as yeast fermentation, where yeast converts glucose into ethanol and excess carbon dioxide. It also generates the energy for the yeast to survive. The reaction we've observed was slow reaction, and the factor that affects the rate of reaction was temperature. If you can remember, we made sure that our water was warm, around 95 degrees Fahrenheit. This temperature helps the yeast to activate and react faster, but still, it is not fast enough to be considered as a fast reaction. The rate of fermentation of yeast depends on the temperature of environment around it. If we refrigerate the mixture, the yeast will ferment and produce carbon dioxide slowly. On the other hand, if we leave it in a warmer temperature or environment, it will ferment faster. This is because warmer temperature increases the kinetic energy of particles. To put it simply, the particles will move much faster and more random, leading to a greater chance of particles to collide with each other and react, causing the rate of reaction to be faster. There are more factors that affect the rate of reaction of chemicals, such as concentration, pressure, and use of catalyst or inhibitor. But we will leave those factors for the other group to explain. Goodbye and thank you for watching.